Today's lecture will cover radiation protection through quality control. Activities that are characteristic of quality assurance, also known as QA, and quality control, also known as QC, have become important for radiation protection. Quality assurance comprises all of the management practices by the imaging physician to ensure that every image procedure is necessary and appropriate, that the images contain the solution to the problem, that the recorded information is correctly interpreted and made available in a timely fashion, and that the exam results in the lowest possible exposure, cost, and inconvenience to the patient. Quality control is a series of technical procedures which ensure the production of a satisfactory product that provides quality that is satisfactory, diagnostic, dependable, and economic. Dose optimization is outlined by the International Commission on Radiologic Protection, also known as the ICRP. They work to keeping exposures as low as reasonably achievable. There are two levels: design and function of the imaging equipment, and imaging techniques and protocols. QC involves 3 steps. Acceptance testing: does the equipment meet specifications? Routine performance evaluation is monitoring components that affect dose and quality, and error correction evaluates the QC test results for service or recalibration. Responsibilities must be defined. A radiologist is in charge of facility, or the department assumes primary responsibility for the entire program. The owner is responsible for radiation safety of the facility. Equipment and facilities is installed and meets all safety standards, and then a radiation safety program is developed and duties may be delegated as assigned. QC is everyone's responsibility. QA principles and test procedures involve the name and the purpose of the test, the equipment needed, how often it is performed, the equipment setup and measurements, documentation of the results, and measures for correction. There are defined limits, acceptance, or tolerance. All parameters that affect dose and quality must be subject to QC monitoring. Tolerance limits are established by radiology and medical physics organizations such as the American College of Radiology, also known as the ACR, and the American Association of Physicists in Medicine, also known as the AAPM. They can be a pass-fail basis, which is qualitative, or they can have assigned values, such as within plus or minus 5%, which is quantitative. If the tolerance limits are exceeded, either there is a need for repair or recalibration. In summary, effective QA/QC programs will help to reduce dose and to optimize exposure. A calibrated dosimeter must be used to ensure accurate dose measurements and to set parameters to perform tests and evaluate results.